Okay, today we're going to be talking about how to find the area between two polar graphs. And so this first example, they give us the graph r equals 3 sine theta, and they want us to find the area that is inside of that graph, but at the same time outside the graph of r equals 2 minus sine theta. So for this problem, we are going to use green for r equals 3 sine theta. And after a while, you will recognize what the shapes of these polar graphs are. But for now, we're going to sketch them by using the basic angles, so theta and r. So we'll pick 0, pi over 2, pi, 3 pi over 2, 2 pi. And we plug 0 in and we get 0. Plug in pi over 2, sine of pi over 2, sine of 90 is 1, so 1 times 3 is 3. And pi is the same as 0 because they're both on the x-axis, so that's going to be 0. 3 pi over 2 is going to be negative 1, so 3 times negative 1 is negative 3. And then 2 pi is the same as 0. All right, so we are going to go at the origin. We're going to go 0 radius. And then we're going to go 3 units up on the y-axis, or 3 units in the direction of 90, put a point, and then 0 units in the direction of pi, so that means we stay at the origin, and then negative 3, which means 3 units in the opposite direction of 270, which basically puts us back here at 90. So this is going to be just basically a circle with a diameter of 3, and that's not a good circle, but you got the idea. All right, and you'll start to see that if this was 5 sine theta, the diameter would be 5, and the sine of theta means it's going up and down the y-axis. If we were to change this to cosine of theta, then it would be the diameter, and then it would be along the x-axis here. All right, so now we're going to sketch the other curve, and that is r equals 2 minus sine theta. So bring that down, and we're going to pick the same angles, 0, pi over 2, pi, 3 pi over 2, 2 pi. Plug in 0, sine of 0, 0, 2 minus 0 is 2. Pi over 2 is 90, sine of 90 is 1, 2 minus 1 is 1. Pi, sine of pi is 0, 2 minus 0 is 0, is 2. And then 3 pi over 2 is, the sign of that is negative 1, so you actually have 2 minus a minus 1, which gives you 3. And then 2 pi is the same as 0, so that's an easy one, and that's going to be 2. So for this graph, we're going to go 2 units in the direction of 0 degrees and put a point. 1 unit in the direction of 90 and put a point. 2 units in the direction of pi, put a point. 3 units in the direction of 270 and put a point, and then we're back here. So this one is going to look like this. It's going to come around and look something like that. All right. So we want to find the area that is inside of the green curve. So we will say, make that red. So inside the green curve, but also outside of the yellow curve. So the area we're looking for is the red area here in this region. Now, what we're going to do is we are going to use what I'm going to call the windshield wiper method. And we're going to go from the origin, and we are going to draw a radial line that goes through where the graphs intersect. All right, and all this is going to do is this is going to help us visualize just exactly what area that you are capturing whenever you integrate. So let's say we are integrating the green curve from this angle, whatever it is, to that angle. So maybe I will put some dots right here so you can see exactly where these graphs intersect. Well, it's important to know that you are going to get not only the red area, but you're also going to get this little area right here as well when you integrate the green curve from this angle to that angle. You're going to get the red area plus the blue area. But if you integrate the yellow curve from this angle to this angle, then you will only get the blue area. So take a wild guess what we want to do if we only want the red area. Let's review. If you integrate the green curve, you're going to get the red and the blue area. If you integrate the yellow curve, you're simply going to get the blue area. If you can imagine this windshield wiper sweeping this area across, but it's only covering the yellow graph, then you're going to get that blue area. So in this problem, we need to subtract. That's the key word. We want to subtract the areas. So we are going to, first and foremost, we need to see where these graphs intersect. So we're going to set them equal to each other. So 3 sine of theta equals 2 minus sine of theta. Bring the sine of theta to the other side. You get 4 sine of theta equals 2. So sine of theta equals 1/2. And so on the unit circle, the sine is equal to 1/2 at theta equals pi over 6, and theta equals 5 pi over 6. All right, so if we want to find the area of just the red portion, then we need to integrate the green curve. So we will say we're going to use our formula that we learned in the last video, 1/2 from pi over 6 to 5 pi over 6. And that's going to be 3 sine of theta squared d theta minus, now we're going to integrate the yellow curve, so that's going to be 1/2, and that's going to be 2 minus sine of theta squared d theta, and it's also going to go from pi over 6 to 5 pi over 6. And that is the integral. They don't want you to evaluate it. They just want you to set it up. Okay, so now we are given the problem, sketch and set up an integral used to find the area of the common interior of r equals 3 cosine of theta and r equals 1 plus cosine of theta. And so we will graph this one in yellow. And so we will make ourselves a table. And in this column we'll put theta, and this column we'll put r. And from the previous problem, we already should know that this is going to be a circle that is going to have a diameter of 3 that goes along the x-axis. But just to make sure that we are convinced of that, we are going to plot points. And we're going to use all the basic points that we've been using. And when you plug in 0, you get 3. Plug in pi over 2, cosine of pi over 2 is 0, so that's going to be 0. Plug in pi, and cosine of 180 is -1 times 3 is -3. And then cosine of 3 pi over 2 is 0 once again. And 2 pi is the same as 0, so that's going to be 3 as well. So you plot those points, and it's going to end up being a circle. And so we're going to draw a circle there, and that is going to represent our graph, r equals 3 cosine of theta. And then in green, we will draw r equals 1 plus cosine of theta. So we're going to do the same thing. We're going to make a table. And we'll say 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so when theta is 0, we get cosine of 0, which is 1. And 1 plus 1 is 2. And then cosine of 90 is 0 plus 1 is 1. And then cosine of 180 is -1 plus 1 gives you 0. And then 3 pi over 2, cosine of that is 0, plus 1 is 1, and then 2 pi will always be the same as 0, so that's going to be 2. So we are going to go 2 units in the direction of 0, and we're going to put a point, and then 1 unit in the direction of 90, and we're going to put a point right there. 0 units in the direction of 180, so that's going to keep us at the origin. 1 unit in the direction of 3 pi over 2, that's going to be down there, and then we're back here. So this one is going to look like this. It's going to come down there, come through there, and come up there like that. And so it is asking us to find the area of the common interior. And so we will kind of highlight that here to make sure that we know exactly what the area that we are trying to find. We are interested in this area right here. And you can see that this area is going to include the area that you'll get from integrating the green curve, and then you're going to have to integrate the yellow curve. So what we'll do is we will draw our radial lines, and we'll draw a line from the origin. It goes through the intersection points, and then we'll draw another one that goes through these intersection points. And you can see that our shaded area is going to include this area here that is going to be obtained by integrating the green curve from this point to this point. And then there's a little bit of area here that we are going to need to capture by integrating the yellow curve as well. So the first thing we want to do is we need to see where these graphs intersect each other. And so we're going to set them equal to each other. So we're going to say 3 cosine of theta is equal to 1 plus cosine of theta. So we're going to move the thetas, cosine theta to the other side. We get 2 cosine of theta equals 1. So cosine of theta equals 1/2. And so when we think about the unit circle, the cosine of theta will equal 1/2 at pi over 3 and 5 pi over 3. So that would be this angle here and that angle here. Now, there's something that I want to introduce here, and I mentioned it before. We actually do not need to integrate from 5 pi over 3 to pi over 3. We can make use of symmetry in this problem. We're going to use symmetry. And if you take a look at this, you can see that this shaded blue area, there's the same amount above the x-axis as there is below. So really, all we need to do is we need to integrate the green curve from this angle to this angle, and then we need to integrate the yellow curve from this angle to that angle. And then the next thing we want to make sure we need to do is we need to add those two areas together. In the last problem, we had to subtract them. Here, we're going to add them. So we have to remember, since we're using symmetry, that we need to multiply our final answer by 2. So let's see if we can set up the integral. The green curve is going to be 1/2 the integral from 0 to pi over 3. So that's this portion right there. And the green curve is 1 plus cosine of theta squared, d theta. And then we're going to add to that the integral of the yellow curve, and that's going to go from, well, let's just see where it's going to go from. It's going to go from pi over 3. And then you have to think about, where does this yellow curve get back to the origin? Well, if you notice right here that the yellow curve gets back to the origin when the radius is 0. When the radius is 0, you're at the origin. So that's going to be at pi over 2. That's the first time it reaches the origin. So we are going to integrate from pi over 3 to pi over 2. And the yellow curve is 3 cosine of theta. And we're going to square that, d theta. And we have to remember that we are only integrating the upper half of the area, so we need to multiply our entire integral by 2 and double it, which is basically going to cancel the 1/2 out, and it's going to leave you with 1 there in front of the integral. And that is the setup for this problem. All right, in this problem, we are asked to sketch the graph of the curve r equals 2 plus sine of 2 theta. And then in part B, we are going to find the area bounded by the curve and the x-axis. So we ought to be a pro now at graphing these. And so we'll put theta here, put r there. So 0, pi over 2, pi, 3 pi over 2, 2 pi. And when we plug in 0 for theta, we end up getting 2. Plug in pi over 2. Well, we have to remember that we have to double pi over 2 because of this coefficient right there. So if you double pi over 2, you get pi, and the sine of pi is 0, so you end up getting 2 again. And then you plug in pi, that's going to make that, you double that, it's going to be 2 pi. The sine of that is 0, plus 2 is 2. And the same thing happens here, and the same thing happens here. So you just get 2 for every angle. So we're going to go 2 units in the direction of 0, 2 units in the direction of 90, and 2 units in the direction of 180, and 2 units in the direction of 270, and 2 units in the direction of 2 pi. All right. Now, you won't be able to see this unless you get an angle that is between 90 and 180. But there's another point, actually, if you graph it on your calculator, it looks a little bit like, kind of like there. And so this graph looks like this. Something like that. All right. And I am not going to go underneath the x-axis because the problem says that the area is going to be bounded by the curve and the x-axis. And so essentially we are looking for this area right here. All right, so that should be a pretty simple problem now. We are just going to integrate from, well, we're going to need to put a 1/2 out front, and we're going to integrate from 0 to pi, because pi is where the curve hits the x-axis for the second time. And so 0 to pi, 2 plus sine of 2 theta all squared d theta. And we're going to plug that into our calculator, and we end up getting 9 pi over 4 if we're in exact mode. Or if we're in approximate mode, it would be 7.069. All right, in part C, it says find the angle that corresponds to the point on the curve with an x-coordinate of -1. So for this, we have to remember something that we learned in the previous video, and that is that x equals r cosine of theta. All right, so we have to now take this r and plug it into here, and it says an x-coordinate of -1. So that means our x is going to be -1. Our r is going to be simply the r they gave us in the problem, which is 2 plus sine of 2 theta, and then times cosine of theta. And I'm going to go ahead and distribute this in. So we have -1 equals 2 cosine of theta plus cosine of theta times sine of 2 theta. Now you have two different approaches that you can use here. Either A, you can graph this on your calculator, and you can set your window, I believe it says from 0 to pi. So you can actually just use x's for this instead of thetas. Doesn't matter, the calculator doesn't care what letter you use. And so you can graph on your calculator this equation, and then you can also, so let's say we'll put this into y1, and we'll put this into y2, and you can find the intersection. But another way of doing it is you can use the solver. You can use the solver on your TI Nspire. And so if you type this into your calculator, you're going to simply make sure you put comma x after that, and you can use the solver, and you will get an x coordinate of 2.63 radians. So that is the angle, 2.63 radians. And I said x coordinate, excuse me, the angle is what we're looking for in this problem, 2.63 radians. All right, so now in part D, it says find the value of dr d theta at the instant that theta is equal to 5 pi over 7. What does your answer tell you about r, and what does it tell you about the curve? All right, so we have our r, and we say we want to do dr d theta. Now, since we're going to use the calculator here anyway, there really is no point in finding the actual derivative of r. I mean, we could take the derivative and it would be 2 cosine of 2 theta, but instead we are going to use our calculator, and I want you, if you have a TI Nspire, I want you to go to, matter of fact, I want you to go to menu, and then you're going to go to calculus, and then you're going to go to derivative at a point. And you're going to type in your point, which is going to be 5 pi over 7. And so essentially this is what you should have on your screen. And you should have, actually you could use x instead of theta if you wanted to. And it would be 2 plus sine of 2 theta. And then there'll be a straight line, and then theta or x, whatever, is going to be 5 pi over 7. Or you could just take the derivative by hand and plug in 5 pi over 7. Either way, you're going to get a dr d theta is equal to negative 0.445. Now, what does this tell you about r? Well, the fact that this value is 0. Let's just kind of analyze what it is. dr, we'll call that the change in the radius. And then d theta, that is your change in your angle. So what is this saying? As the angle is changing, the radius is getting smaller because this is a negative value. So that simply means that the curve must be approaching the origin. So that's what you'll say. The curve is approaching the origin. And the other question here is, what does it tell you about the radius? Well, it just tells you that the radius is getting smaller as the angle is changing. Okay, in this last problem, we see that a particle is traveling along the polar curve given by r equals 2 plus sine of 2 theta, and they say the position at time t is x of t comma y of t, and they give you d theta dt equals 3, and it wants you to find the value of dx dt at the instant that theta is equal to pi over 6, and then interpret the meaning of your answer. So anytime that we are asked to find dx dt, that is a clue that it is a related rate problem. So we're going to have to treat this like a related rate problem. So we are going to start with x equals r cosine of theta, and we learned that in the last video. But they give us r. They tell us that r is 2 plus sine of 2 theta. So x is really 2 plus sine of 2 theta, and all of that is times cosine of theta. So we're going to have to take the derivative of this, and we are going to have to use the product rule because we have a function times another function, And we're also going to have to take the derivative of this with respect to t, because it's a related rate problem. So we are going to take the derivative of the left side, which gives us dx dt. And on the right side, once again, like I said, we're going to use the product rule. So we'll take the first function, which is 2 plus sine of 2 theta, times the derivative of the second function, which is simply going to be negative sine of theta d theta dt. Don't forget, this is a related rate problem. So every time you take the derivative of the one of the variables, you need to include a d theta dt after that. And then you have plus the second function, which is cosine of theta, times the derivative of the first. Well, the derivative of 2 is just 0, and the derivative of sine is going to be cosine. And we're going to use the chain rule here, so we're going to leave 2 theta alone, and then we're going to multiply by the derivative of 2 theta, which is 2, and then we're going to multiply by the derivative of theta, which is d theta dt. All right, so they tell you that theta is equal to pi over 6, and they give you d theta dt equals 3. So all you do is plug both of these values into this complicated derivative, and you will get a dx dt that is approximately negative 1.70. So now it's asking you to interpret the meaning of your answer in the context of this problem. So if let's say we draw an xy plane, and it says that we want to find dx dt at the instant that theta is pi over 6. And so pi over 6 is 30 degrees, so we're somewhere around here. So when the particle is at this point, it says that dx dt, or let's just write it out this way, the change in x, quote, as the time is changing, so change in time. So as time is changing, the x-coordinate is decreasing. It is negative. So that means that the particle is moving in that direction. And so what you will say is that the particle is moving towards the y-axis. Now you can't say it's moving towards the origin or whatnot, because it could be going up here, could be down here, but it is definitely moving towards the y-axis. And other than that, that's all you can deduce from this.